to all. Welcome back to Google Classroom on Sri Gokulam Public School, Guruvayur. Today we are going to discuss about a new chapter number 10, vector algebra. See, in last class we seen the differential equation. There we discussed how to find the solution of differential equation, especially homogeneous differential equation as well as linear differential equation. Okay. So, you have to thorough with the concept of homogeneous as well as linear differential equations. Okay. Anyway, today we are going to discuss a new topic, vector algebra. Actually, vector algebra, you are familiar with the term vectors, isn't it? So, vectors is a quantity that are having magnitude and direction. See, in physics you already heard that the terms quantities. Okay, some quantities are having only magnitudes, quantities only, magnitudes. At the same time, some objects or whatever it is having magnitude as well as what direction. Such type of quantities are actually called vectors. Is clear? A simple example, distance and displacement. Distance is a position only from one point to another point, isn't it? We can move from A to B or B to A, that is a distance or length. So it is a magnitude only, quantities having magnitude only, that is scalar quantities, isn't it? Scalar quantities. At the same time, if you are giving a direction from a point to another point, then it is called, such type of quantities are called vectors. So in this chapter, we are going to discuss about vectors. How can I add two vectors, what is the algebra of vectors, and some special type of vectors. Okay, all these things we will discuss in this chapter. Anyway, watch the video carefully. Okay, let's start. Chapter number 10, vector algebra. I already told vectors. Vectors are quantities having magnitude as well as direction. Okay, so let's start with our quantities having magnitude plus direction. So listen, suppose we have a line segment. Suppose we have a line only. Okay, suppose we have a line, and if we give a direction, give a direction to this line, then this line is called directed lines. Okay, directed lines. These lines are called directed lines. Now, if we take a segment on this line, AB. So this segment becomes directed line segment. Directed line segment AB. Directed line segment AB. Okay. So in this directed line we are taking a line segment. Then this line segment AB is now called directed line segment AB. So this directed line segment having a magnitude. Magnitude means a length and a direction, and therefore this directed line segment is called vector AB. Okay, vector AB, and it is denoted as, vector AB. Read as vector AB. So starting from A and ends at B, that is the meaning of vector AB. And this vector AB is also denoted as vector A. Okay, vector A. Consider this xy plane. This point is origin, and take a point P here. P is a point with the coordinate xy. And now join O and P and give a direction from O to P. So O is initial point and P is terminal point of the vector OP, isn't it? Vector OP is a vector quantity with initial point O and terminal point P. And see this vector with initial point as origin, and therefore this OP vector is called position vector. Position vector of the point P with respect to O. Is clear? So any vector starting from the origin, then it is called a position vector. Is clear? This is a three-dimensional plane. Okay, three-dimensional figure. And x-axis, y-axis, z-axis. These three axes are perpendicular to each other. Listen, actually this x-axis is perpendicular to both y and z-axis, just like this. Okay, so in plane we can represent x-axis is like this. So you can consider this 3D or xyz plane and consider a point P in this plane with the coordinates x, y, z. Okay, x, y, z. Now draw a vector OP. OP is a which vector? Position vector, because OP vector is starts from origin. So this is a position vector of this point P with respect to this origin, and position vectors are often denoted by the vector R. Okay, vector R. And this position vector makes an angle. Okay, makes an angle alpha with a positive x direction. The position vector R makes an angle beta with positive y-axis. Position vector R makes an angle gamma with positive direction of z-axis. It's clear? Alpha, beta, gamma. Now, cosines of these angles, that is cos alpha, cos beta, cos gamma. Cosines of these angles are known as direction cosines. See the word direction cosines. Okay. So alpha, beta, gamma are the angles made by this position vector with respect to positive x-axis, positive y-axis and positive z-axis. Now they are cosines. Cos alpha, cos beta, cos gamma are called direction cosines. Is clear? Direction cosines. See, in this figure, if we consider the position vector OP and draw a perpendicular line to the y-axis. So what is this length? This length is y. What is this length? This length is z. What is this angle? This angle is theta. Because position vector makes angle with the positive y-axis as beta. So what is cos beta? Cos beta is adjacent side by hypotenuse. What is adjacent side? Adjacent side is y. Hypotenuse. What is hypotenuse? It is position vector r. So cos beta is equal to y by r. Okay. Cos beta is equal to y by r. So from here, cos beta is equal to y by r. What is y? Y equal to r cos beta. Y equal to r cos beta. Similarly, we can define x and z. X equal to r cos alpha and z equal to r cos gamma. Okay. If we consider separate right angle triangles, we can see that x equal to r cos alpha, y equal to r cos beta and z equal to r cos gamma. And listen here, these r cos beta, r cos gamma are cos alpha. All these are called direction ratios. Direction ratios, and these are represented by A, B, C respectively. That is, A is r cos alpha, B is r cos beta, C is r cos alpha. And also these direction cosines are denoted by the letter L, M, N. Okay, L, M, N. That is L equal to is an x by r. That is cos alpha. M equal to y by r. That is cos beta. N equal to z by r. N means cos gamma. Okay. Cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma are direction cosines. Okay, direction cosines. And L equal to XR. From here we can write X equal to LR. See here, X equal to, this is L, LR. Y equal to MR. From here, cos beta is M. So Y equal to MR. Z equal to NR. So these X, Y, Z or LR, MR, NR are called direction ratios and it is denoted by A, B, C. So note down direction cosines as well as direction ratios. Okay. Types of vectors. Let's see different types of vectors. First one, zero vector. Zero vector or null vector. So here vector means it has magnitude as well as direction, isn't it? Magnitude as well as direction. If magnitude is 0, means vectors are starting with same initial point and ending with the same point. That is, initial point and terminal points are coinciding point. In that case, in that case there is no magnitude, there is no length, and therefore such type of vectors are known as zero vectors. Just like vector AA, vector BB, all these vectors are zero vectors because here initial point and terminal point both are same point, just like a point. In this case there is no magnitude, measurement, there is no measurement. Therefore these type of vectors are known as zero vectors. Now second vector is unit vector. Unit vector means any vector having magnitude equal to 1. Okay, if magnitude, length of the vector is 1, then that type of vectors are known as unit vectors. Suppose we have a vector A, and there is a unit vector along this vector, then we can represent this vector as a cap. Unit vectors are denoted by a cap. And listen, magnitude of such type of unit vectors is equal to 1. Okay. Now another type is equal vectors. Equal vectors. So vectors means, suppose we have two vectors, vector A and vector B. Okay, vector A and vector B. And listen, these vectors having same magnitude and same direction. Any two vectors having same magnitude and same direction are called equal vectors. No need to consider their initial points or terminal points. Okay. Suppose they have same length, same magnitude and same direction, then the given two vectors are known as equal vectors. Now another set of vectors are co-initial vectors. Co-initial vectors. So from the word itself it is clear that co-initial means vectors, all the vectors having initial point are same. Okay, just like this is the point O, vector OA, vector OB, vector OC, vector OD. All these vectors starting from O. That is, O is the initial point. So OA vector, OB vector, OC, OD. All these vectors are co-initial vectors. Is clear? Vectors. Collinear vectors means, suppose we have vectors AB, then BC, CD, EF. Okay, consider these vectors and imagine suppose these four are parallel lines. Okay, parallel lines. Without considering their magnitude as well as direction. Never consider their magnitude and direction. And not these lines are parallel to each other. Okay. So such type of parallel vectors are known as collinear vectors. Okay, so two or more vectors are collinear if they are parallel vectors without considering their magnitude as well as direction. Is clear? Collinear vectors. So, equal vectors, then zero vector, unit vector, co-initial vector. This one is collinear vectors. Okay, negative of a vector. What do you mean by negative of a vector? Listen, suppose we have a vector A, B and see the direction. Okay, see the direction, negative of a vector. So, consider this. See the direction from B to A. Here the direction is from A to B. Here it is from B to A. So, negative of this vector is vector BA. Clear? Vector BA is the negative of the vector. Which vector? Vector AB. And this BA can be written as negative of AB. Is clear? So direction will change. That's only about negative of a vector. Okay? Algebra of vectors. How to add, how to subtract or how to multiply any given two vectors. Let's see. The first one is addition of vectors. Suppose we have two vectors, then how can we add these two vectors? Listen, suppose there is a vector, vector AB and another vector, vector BC. Okay, there are two vectors AB and BC. Now join AC. Okay, now join AC. So, this AC vector represents, listen, the sum of these two vectors. Let us take vector AB as vector A, vector BC as vector B. Then, sum of these vectors is actually vector AC. That is, vector A plus vector B. Is clear? So, in this triangle ABC, vector A plus vector B gives its third side. Vector A plus vector B. This is called triangle law of vector addition. Is clear? Triangle law of vector addition. At the same time, listen, if we draw a parallelogram, and we know that in a parallelogram, diagram divides the parallelogram into two congruent triangles. Let us take this triangle as ABC, this triangle as ADC. Consider AB is vector A, BC is vector B. If AB is vector A, then what is BC? BC is also vector A, isn't it? Now, if BC is vector B, then what is AD vector? AD vector is also vector B because ABCD is a parallelogram. Parallelogram means both pair of opposite sides are equal and parallel. Is clear? Now, in this triangle ABC, what is AC vector? What is AC vector? AC vector is A plus B because AB is vector A, BC is vector B. Therefore, AC is vector A plus vector B. Is clear? Now, in this case, ABC, in this triangle, AD, vector AD is vector B, vector BC is vector A. So, what is AC vector? Vector B plus vector A. Vector A plus vector B is same as vector B plus vector A. That is, vector addition is commutative and this result is known as parallelogram law of vector addition. This is triangle law of vector addition and this one is parallelogram law of vector addition, and also known that vector addition is commutative. And also you can see that vector addition is associative also. Okay. See, all the things are explained forms are given in your textbook. Go through the textbook. You can easily catch all the things that how to add or how to prove commutative property, associative property of vectors given. Is clear? Now subtraction of vectors. See, in this triangle AB vector is vector A, BC vector is vector B and AC vector is vector A plus vector B. That is triangle law of vector addition. Let's see, just extend this line from C to D having equal magnitude. Let us take C dash and this direction becomes like this. So this vector is actually BC dash vector. Isn't it? BC dash vector. So BC is vector B. What is its BC dash vector? Negative of this vector BC, isn't it? BC dash vector is negative of this vector BC. So if BC is vector B, then what is BC dash vector? It is negative vector B because negative vector. So in this triangle ABC dash, listen, in this triangle ABC dash, AB is vector A, BC dash is negative vector B. So what is AC dash? AC dash is vector A plus minus vector B. What is vector A plus minus vector B? It is A minus B. Vector A minus vector B. So this is known as triangle law of vector subtraction, or simply subtraction of two given vectors using triangle law of vector addition. Okay, we know how to add any two vectors, how to subtract any two vectors, isn't it? Let's see how to multiply two vectors. So here multiplication of vectors means multiplication by a scalar only. What do you mean by scalar? Scalar means is a magnitude, a quantity having only magnitude. That means suppose we have a vector A. So we can multiply this vector with a scalar. For example, 3 into vector A, 4 into vector A, minus 2 into vector A. This is the meaning of scalar multiplication of a vector A. Multiplication by a scalar. So by using a scalar quantity we can multiply any given vector. For example, suppose we have a vector, this vector A, and its magnitude is suppose 8. Magnitude is 8. Now if we multiply this scalar with this vector with a scalar 1 by 2, 1 by 2A. So what is 1 by 2 into vector A? 1 by 2 into vector A is magnitude is 8. So 1 by 2 into 8 is 4. It is another vector C, vector B, and its magnitude is 4. Is clear? So vector A is magnitude, having magnitude 8. Vector B is a vector multiplying a scalar with this vector A. What is the scalar? 1 by 2. Is clear? If we multiply this vector with a scalar 2, we get this vector. So we can multiply a vector by a scalar only. Is clear? Now listen, there is no change in the direction. If we multiply any given vector with a scalar, whatever the direction have the original vector, original vector, as such we can follow the remaining means the resulting vectors just multiplied by a scalar. There is no change in the direction. Is clear? There is a change in magnitude, but after multiplication there is no change in the direction. Is clear? So multiplication by a scalar.